Habari za mchana.
Salama mwalimu.
Tumai weekend imeanza vizuri.
Kabisa.
Okay. As I gave notification from our WhatsApp group, there is a power cut here at Changanyikeni. And I'm not sure how long my PC will last with the power. If it happens that the session and before we even accomplish the first hour, tomorrow I'll offer another session to complement this week because we have only one session per week. So if we miss huge part of the session, it will be a disaster for the whole week. Another thing, I apologize, I didn't put an exercise as I promised because I was so busy restructuring the content of these 2 weeks sessions. I will upload the handout very soon, but I have renamed them. The one which was written data R package installation now will read as R package management by using base function. And the other one which we're going to study today will be R packages management by external functions because they do possess similar characteristics in some of the issues, but there is some modification in other sides of the functions. So as for this part, we already covered this. We highlighted about R packages last time, and it is a toolbox we said which contain R functions, documentations of the functions, and even the package as a whole, and even sample data. And we said you have 2 kinds of packages. You have base packages and external packages. And the major difference is the base packages, it is a part of R software. The moment you install the software, they are already there. They are installed alongside with the software. And whoever is using R must have this. So you're going to have similar functions as long as you're keeping use base R. But also R have provided rooms for external packages. And these play a major role to make sure R is user friendly. For these external packages, you must install them on your computer. They are not part of the R when it is installed. And for the first time you install them, you must be connected to the internet. And each time you close and open R software or you restart R session, you'll need to activate them by using either library or require functions. I have covered this last time, and this is the list of base packages. You have seen them. External packages, we need to install them. And I pointed out about the R's ecosystem repository. And we even hinted it is like a Play Store in our smartphone. So it is a repository. Each time you go to fetch a package, it's like you go to a Play Store in your smartphone to fetch an app. So this is like it. And here I listed the 6 common repositories, which we have covered last time. By default, always are use CRAN as a repository, source repository. This is an official repository for R. Each time we want to install a package, it will be fetched from here. But I have also seen there is another repository called Bioconductor. It is very rich when it comes to biostatistic and medical R packages. And we have also seen the P3M, Positive Public Management Manager. This one does the same stuff as a CRAN and a bioconductor because it will go back here. But it is very fast in terms of installation, but also it gives you the room to install a specific package to install a package from a specific date. So that is the P3. And these three, I pointed out last time that this provide stable version packages, which are already passed the official testing and are hosted in this repository. But sometimes you may need to use some other packages which are still in development phases, and you'll have them from GitHub. GitHub is the house which is used to comprise or for development of packages and some other stuff other than R. Last time we covered the first three, and today I will partially go through the other three, which host packages which are yet to be in a final stage. Because once the package passes all stages, will be hosted either in CRAN or Bioconductor. But these are also important because sometimes you may find a package which is completely new. The package which is completely new, you cannot find it in CRAN. So you will find it in this other repository. But sometimes the package may be already existing, but the most recent package, which is the updated version, it is yet to be hosted in CRAN. So you'll also find them in GitHub, and these are universe and the multiverse. So we talked about how to install this. We talked about CRAN repository, and this is yes. This is how you can access CRAN. We talked about this last time. So each time you want to install a package, when you put installed packages, automatically it goes to CRAN. And this we already covered. I will go directly to GitHub. GitHub, we say it is where almost all R developments happens. In the R community.
أنا session يا آلة.
When you install in our community, GitHub is not regarded as a repository, but it is a source code. It is somewhere where you can fetch code if you're developing a package. So when you install package from GitHub, R will download the code and build the package on your computer. So it's not like you are downloading the package, but you are downloading the codes, and the R tools will help to build the package directly in your computer. In order to do that, we need a bridge packages, just like Biocommand when you were installing package from Bioconductor. And the tools here are remotes, Devo tools, and package. But the remotes, it is a light version of Devo tools, and the pack is the most recent function which can enable installation of a package from GitHub without with no problems. So first of all, you must have your bridge packages in place. So you'll install them. We know that when you want to install more than one package, we have to use the C functions. Have to use the C functions. So I put the demo of that. Check. Okay. We are here in package installation. install package from GitHub. From GitHub. If you want the most recent package, you will come here. So here we are. So first of all, you have to install this. So we all know how to install this. So I'll not go for this one, but I'll put a syntax here. Installing bridge packages. I'll put a syntax here for your reference. Installing bridge packages. So you must have either remote or pack in place. So once you have those, then as usual, should make use of the function called install GitHub. The format is you must start with the author or institution name, then a package name. Like here, I'm going to demonstrate by using tinyplot. We are going to install tinyplot package, but it was developed by these guys here. Grant MC Demot is the one who are responsible to develop this package. How do you get this? Because this one is a username in GitHub. I'm going to show this later. Username from GitHub here. Something like this. If I click it here, this is the GitHub of this guy who is developing tinyplot. So you'll find here, after the address of github.com, what next is that username and then the package. So here, they are hosting source codes for this package, which we are going to build in our computer. So let me go back. So you will say here, remote, then install GitHub. Install GitHub. And what do you have? It is this last part here from GitHub. So you go to the URL from GitHub, paste it from there. So after that, make sure you are connected with the internet. So it will do that stuff for you. Skipping all tinyplot, digital what has no sense. Use force. Pro. For me, since last installation, maybe I should remove it first. Remove the packages. Tinyplot. Sorry. Remove the packages. No changes since last time installation. That's why throw such kind of error. Let me remove this one first. So once it is removed, I can go back and do the installation. So this will build the package from GitHub to your computer. Note that in order to do this, you must install other tools, because other tools will do the job of compiling the package. But you don't need to worry, because we are going to learn a suitable alternative very soon, which will make you to avoid the use of other tools very soon. But here now you see it is building the package from the scratch. While it is still doing that, I can give you a little bit of introduction. First of all, find the author organization name for a GitHub package. As I pointed out, it is usually straightforward from URL. When you go to URL, you will find that username here. Immediately after github.com, what next is the organization name or developer name. And after that, it is followed with the package name. And also GitHub URL always follow this specific pattern. It starts with https github.com, then author name, then package name. So from this format here, this grant so-and-so is the author name, and this tiny plot is the package name. And this part from author name and package name are the one which are going to pick and put them under double quotes when you want to install the package from GitHub. So here we are. It says warning, packages in use and will not be installed. I think it is still removed. No. Okay, for my case, it was already there. Maybe that's why it gives you some challenges. But in your case, it will work perfectly fine. Another way of doing that, you can also install it by using package, then pkg install. So these are two different platforms which you can use. Package install. You can do the same thing from here. So you have alternatives either by using remotes or by using pack. They call them bridge packages, or they call them translator. They use it to translate the code for. They're going to translate the code for CRAN. Pack from CRAN will translate the code from GitHub and proceed. That is number one. We cannot wait until when it finishes. I should move forward. Now, R Universe repository. Actually, what is this? It was developed recently. I think it was in 2024 by these guys, R Open Science, which allow every other R users organization to have their own personal CRAN. You can develop this by skipping this stuff here. R Universe will bypass the need for R tools because it has already built the window binary for you. So nowadays, even if you don't have R tools, still you can install package from GitHub with no problem. Install package from R Universe. Sorry. I think I've clicked this somewhere. Yeah. This one, it is still working. So here, install package from R Universe repository. What it does, from R Universe repository, the same stuff. The standard R Universe is in this form. It always starts with HTTPS and then username. That username from GitHub, and then .runiverse.development. And then you will use the same command for install.packages. But down here, you will be required to use the option repos for repository. But specifying that, like in that case, the username is this guy, Grant so-and-so. I cannot pronounce this precisely, but the R Universe development. But we also need to add the CRAN repository because most of the packages depends on the packages which are available in CRAN. So if you ignore this repository from CRAN, it may fail to install the packages due to lack of dependencies. So here, you will come here. First of all, I need to check the current repository. There is this function here, get option, and then you say repos. Repos. So what is the current repository? Actually, current repository is a CRAN, and the CRAN is extra. So if now I do install.packages, it will go directly to CRAN. But here I'll say install packages. What is my package? It is tinyplot, package which I want to install. And then I go down here and say repos. Which repository should be accessed in order to install this? We follow this format. I can even copy this. But what is the username? I go to my GitHub and pick that username from there. You put it there. You put it there. If I was to fetch only our university repository, it was fine. But as I said earlier, we also need to add CRAN repository for dependencies. So my CRAN repository, you have several choices. Either you can go back and copy it from here, because it is there. It is here, Cloud R, which I have already produced it somewhere. It is here. CRAN.cloud sensor. So I add it here. Sorry. Now the problem is the moment I put more than one content here, I need to enclose them with C function. We're going to learn about C function, I think, in the next session. So the moment you have more than one argument, C functioning is required, like that. So in this form, here now, you don't need R tools. Do you want to restart R prior to installation? Then just say yes. So here now, if you do that, you don't even need those bridge packages. You don't even need R tools. Just like the way you were installing packages from CRAN directly, you can also do it here. So this is number one. Says in base repos unexpected end of input. Let me check. What is the problem? Pause. Internet. Sometimes it may depend with the strength of your internet. Okay. Let me redo this if it's okay. Yeah, now it's okay. Now it is unpacked. Everything's okay here. So you can do it like that. So instead of using GitHub, you do it like that. Another way of doing it is to come here and change the default. Use options, change repository default. This is option 1. Option 2, change repository default. Currently, if I say get option repos, you see the default is a CRAN. The default is the other project, which is a CRAN. But you can come here and change that by using options command. And these options, the same repos from here, I can copy it and put it here. So this will change the default. So if I rerun this, now you see the first repository is our universe. And then the secondary repository now is a CRAN. After this, you can just now use install.packages as usual without adding any other option, tiny plot. Tiny plot. This will be enough because first this command will go to our universe and then it will go to CRAN for dependencies. So this is how you deal for installing our universe. The problem with that one is always to find the username. So you must be smart enough to find the username. So this one has improved the struggle of GitHub. Now we avoid our tools and we come in here, we install our packages with ease. But other than that, how can we avoid each time looking for this username here? Also, that one has got a solution, and that is go to our multiverse repository. This I'll just explain because it is very similar with the universe. So the collection of several universe repository, because the universe repository is for individuals. Each organization will have its own repository. But now the collection of all those, we call them multiverse. So multiverse is about it. Universe is about a personal and organization level repository, while multiverse is a community-driven project that aim to be a centralized alternative to CRAN. All other packages which are ready to pass, which are not ready, which are yet ready to pass the test to be hosted in CRAN, will be centralized into multiverse. So when you go there, if you click here, multiverse, it will take you somewhere here, our multiverse. And here you have packages repository, there is a community and a production repository. I'll explain about that in a short while. Thank God the power is back. So this multiverse now has two distinct repositories. There is a community multiverse and a production multiverse. When CRAN always has strict rules. If the package fails the test, it gets archived from the CRAN. But you can install them from multiverse. So here, what is the difference between a multiverse community and a multiverse production? Multiverse community here is designed for rapid development and sharing. It acts as a live stream of package updates. Since it is updated continuously, any changes in the source will appear or will reflect instantly in our package. So if you want even the changes of today's morning, you are advised to use our community. It is always give the latest version. But what is the production? The difference is only on updates. Production updating in terms of quarterly basis. I think it is after 3 months. After each 3 months, then this one get updated. It is more stable compared to this because if you use community-based package, the syntax which you have run or you have executed yesterday, it may change a little bit today due to the updates. But this one, expect changes maybe after 3 months. So for stability, we are always advising to use production repository instead of a community repository. Each time it passes 3 months, then the package is hosted in a production repository. Avoid this continuity updates of the package. That's why you have 2 options for multiverse. And can you hear me? My internet was shut a little bit. Nanisikia? Tupo kwanza?
Tupo mkuu.
Nakusikia.
Tupo. Ndio, tunakusikia.
Okay, now
Nakusikia.
let me proceed. Umeme umerudi, so we are good. So our multiverse is not a replacement of CRAN, first of all. CRAN is strict, stable, and the official repository of R packages. While multiverse is flexible, because each time package can get updated, it is fast, because even the updates of today's morning, you can have it, but the packages are still in experiment phases. They are not yet official. So be careful if you want to use a package from Multiverse. But sometimes you may be forced to do so because it is nowhere to be found in CRAN. Many packages start on Multiverse, then move to CRAN once it is stable. And the stability here, it means we don't undergo any further changes until maybe the new update is released. So use Multiverse when you need packages which is not on CRAN, number one. You need the latest development since the last version hosted in CRAN, or you need to use automatic updates, something which is not there in CRAN. Our multiverse is decentralized, continuously updated ecosystem for distributing and testing our packages outside the constraint of CRAN. Packages are automatically updated wherever code changes. No manual submission process like in CRAN. So this is the difference. How do you do the installation? This one I'm not going to do it in practical way because it is very similar to Universe. So instead of putting a username here, the rest are the same. Here you either put a community or production, because here installing our package from Multiverse production or Multiverse community. The advantage of this, you don't need to go and look for username of a particular organization or person or individual. The link is always the same, https://community.multiverse.org. Or if you want to use a stable version for quarterly basis, use the production. And this is what we recommend you to do. The approach is still the same. You write your package here, then repos. Or, first of all, you change the default in options so that the installed packages will go direct to the production repository and look for the packages. We always accompany you to the CRAN due to dependencies. So unlike this, unlike Universe, where you have to use the username here, here always you just need to put a community or production. So among these three, this one, let me go back. We have three issues here. GitHub, Universe, Multiverse, they almost save similar stuff, and that is to install packages from GitHub. I recommend you to use R Multiverse production. It is more stable than the other two with less problems. For number 5 and 6, you don't need R tools. But for GitHub, it is not a repository. It is a source code where R tools can be used to build the repository. Now, at last here, I have summarized the issue of setting options. You have seen the command when you write get options repos, it will print for you the default repository. By default, when you open your R, it is always CRAN. Or if you restart the session, it will always be CRAN. But you can change the default repository by using options. So if like this one, I put options, then let me check about repos, you will see. Change default repository. Change default repository. Instead of CRAN, if I do it like this, now you see my default repository now is P3M instead of CRAN. So you can always change that. So if now I try to say install .packages. The package which I am going to put here, R will go and look it directly to this repository. Since it is not a CRAN, you may not be successful to install this. So that is the lesson about how to change the repository for installation. Now here I have put a summary. Always when you want to change a repository, there is this side here. What comes after equal sign? It is a URL for your repository. Sorry, this one is not supposed to be like this. Yeah, supposed to be like this. This one enclosed with double quotes. It is a URL for your repository. We have learned different repositories so far. And here I have put a summary of 9 repositories. For CRAN, what you specify after repos, it is this one. I think I also need to close them with double quotes. I will close them with double quotes so that you can be able just to copy and paste. Because you cannot use them plain like this. Each repository must be enclosed with the quotes. I will do that before I share the updated version. For CRAN, it is like that. For bioconductor, you remember, for bioconductor, you need to install a package from bioconductor. How? By using bio manager and then install. This is how you can install a package from bioconductor. But you can also use install package as long as you change the repository. So you can say this options, and then repos, then what? Then you do it like this. Bioc manager as usual. Bioc manager, this one. And then repositories. If you run this, now if I go back here and say get options, you will see now our repository are in bioconductor. So this time around, instead of saying install a bioc manager, install so and so, like edge R. Instead of this, now you can go direct and say installs.packages HR after changing the options. If you don't change the options, how you can install package from bioc manager, the style is this one. But if you change the options, you can always go to install.packages and do the same thing. The rest are already done because you can install latest from POSIT by using repos. This is the URL. Wherever you see blue, it means that is the link, hyperlink. You can click there, and it will take you directly. But wherever you see this magenta color, that is a format. Like this one, this is not a link, it is a format. You will need to put your year, month, and day here to install specific date. As for the rest, already covered community, production, our university, remember to put username here. As for bioconductor, you will put this URL, specific date, you will put year, month, day. But remember, the argument is not repos. When you install from bioconductor, it is called bioc mirror. So each time you want to change option, you can put this within what? Like I want to install packages, this form. Which one? Let me check. This one. I want to install package from PM3 CRAN source. First of all, I will say options, options, then I'll paste this. This is what I've said, you need to enclose with double quotes. Now, which specific date do you want? Maybe 2024, March 19, maybe something like that. So first of all, you change this repository. Once you change that, you can check this by using get option. You say repos. So now, if you want to install any package, will be installed from this specific date. Any package you want to install now, first of all, it will go and look at this specific date and start the installation. That is the summary about the package installation. Blue color is URL, magenta color is URL format. Wherever you see magenta color, it means it is a format. You have to put a customization, like here, you put a username, here, you put a specific date. Jamani, kuna swali? That is about the package installation from base function. Hakuna. Now package activation, this one is covered in previous week. Naam, karibu.
Hiyo GitHub umesema yenyewe sio nini? Ile umesema sio ni source, sio kitu gani?
Sio repository, bali ni source code.
Namba hapo.
Okay.
Okay, nilikuwa nataka unisaidie.
Yes, ndio maana nikasema yenyewe hauinstall package. Unachofanya una obtain source code, alafu RTools inatengeneza package kwenye kompyuta yako. Ndio maana lazima uwe na RTools. Sawa?
Sawa.
Yes, lakini Universe package inatengenezwa kabisa. So you're just installing, only that you need to declare the repository source. Tuko sawa?
Sawa.
Okay. Require and the library tumezungumza hii last week. Na accessing package function tulizungumza last week. I have updated that one. Update.packages wengine nitaongea tu kwa ajili ya kuokoa muda. Update.packages itaenda kwenye current repository, itaangalia kama kuna recent version kuliko ulionayo kwenye kompyuta yako other than the one you have in your computer. It will update that package to recent package, like update.packages pacman. Since you have installed, also you can remove the package by using remove.packages, like that. Another thing is access the list of all packages. If you click available.packages, these will print packages and the version of all packages in CRAN. But installed.packages is for only those packages which are already installed in your computer. The other one, this is not available. It's supposed to be old.packages. I will update this, like this one. I will update it before I share the final version. Old.packages. This will give you a list of packages which requires updates. And here, it is a list of package names. List of package names based on different categories. Now, category 1, all packages in CRAN. This will give you names of all packages available in CRAN. And remember, we have more than 22,000. So most of the time, it is very heavy. It does not print more than 1,000. So I'll ignore that. Row names, but rather I will go here for numbers of packages. That one is easy to handle. Numbers of packages. How many packages are there in CRAN? packages in CRAN. How many packages are there in CRAN? We use the function mrow. There are 20,579. How many have we installed? Installed the packages. How many have we installed? mrow installed the packages. 658. And this is my computer. So the number will be different from your computer. But this one, you're going to have a similar number. Huh? Also, how many are old? Among this 658 says nil. It means all packages are already up to date. Require updates. I don't have all the package. So that is a simple summary. Another stuff is to use this package status. This package status can summarize the other stuff which you have encountered so far. It says what? Sorry. Here it says nil, but I'm not sure if I'm okay. I need to change because this one will go to CRAN. The problem is I have already changed the option to something else. So before I run this, I was supposed to change this back to CRAN. Let me change this back to CRAN so that it will be precise. The function will look for something from CRAN. Now I have changed this to CRAN. I'm in CRAN. So you see the number, it is 23,527. These are packages available in CRAN. Installed 658. How many are old? 345. So in my case, I need to update this 345 packages. Yeah, cancel. Package status, it will give you those statistics. Like here, it says the packages you are installed. Installed 611, not installed 22,921 from CRAN. Here it gives you the distribution of repository. Like this one are okay. This one you need upgrades. You see this 345, it is this one. When you add this number, you get 345. So they need upgrade. And these ones are the one which are okay. They are recent. And this one, they are not available. It means they are already deprecated. They are no longer in use. So that is how you can get that summary. So it tells 611 are installed and the 22,911 are not installed. And that is from this statistic here. Package maintainer. First of all, here it is how you can describe a package. So you can check the package version. You can check the package version, which you have currently. Check the package version. Package version. Like here, I can put any package name, like E1071. What is the current version? It is 1.7.17. So you can always check it like that. We have other syntax later on, which I will use to update this. Also, there is a function called maintainer. Maintainer. You want the email contact of the package maintainer. Sometimes you may struggle with your function. And you may look for solution from everywhere, but you cannot get it. You need to go back to someone who developed that package or who is maintaining that package. So this one, if I print maintainer here, you see the maintainer is David Mayer. and this is the contact email. It means you can take this and contact the guy who is maintaining this package. So wherever you are struggling with any function or wherever, you can always use this function to contact someone who has the task of maintaining that. That is another tip. Another stuff is a package description. Package description. Here you will get some information which you have already counted there. But other than that, you will get something more. It gives you so many stuff here. Like the maintainer will be there, the authors give you the package, the version, the title. What does that function do? Import, suggest authors. The author is here, David. And the contact which you have seen there, when was it packed? 2025. And the maintainer is this one. You see that email. So maintainer will just pick this one line. And where was it installed from? It was installed from CRAN. And the date which was published, and its stability is standard, and it even gives you the location. Where is the location of your installed packages? So if you go step by step by following this path, you will find the documentation of this. So that is a package description. You can get a lot of stuff from there. Another issue now is to access or syntax for obtaining list functions. This one, I will skip them because I will do them concurrently with the next slide, which I'm going to do very soon. It is going to be some sort of repetition. So I will do them concurrently when I do the next slide. So this is what we are supposed to accomplish last week, packages management by base function. Now, packages management by external function. Wherever I have used it so far, were the function from base, most of the time. But from external function, there is a package called the Pacman. It is a short form for package manager. Package manager. When you have this function, you can use this to manipulate and get access to some tools of other packages with ease. What it does, it may also be used in installing and loading packages. It can also be used to deactivating the packages, updating, even deleting. You can access package information documentation. You can get a package data and function list. These are just to list a few, but it do more than that. Their functions always started with P underscore, then package name. So always when you see P underscore so and so, it means that is a function from Pacman. What is the advantages, the disadvantages? Why do we need that? Pacman can also be used to install packages. So you can use p install, package management by external function. Here now, first I will name this package management by base functions. And then I will open a new one. Which I will call it day 3. Okay. Capacity building. Which I'll call it day 3. Package management by external functions. So first of all, you will need to install that package. It's called Pacman. We know how to do installation. It is available from CRAN. So you need to install this from CRAN. I need to write a command here, but comment it. Install.packages. Pacman. Note the difference. When you are doing install.pacman package, you must enclose the package name with quotes. But when you're activating, you have choices. Either you can enclose with the quotes or you can ignore. So make sure you have the package ready in your environment. Then what else? You can use now this package to install other packages. Like p-install package names, but also you can use the function p-get. They are doing the same thing. So here, like p_installed. Now, unlike in base, here you don't necessarily need to close with double quotes. Like E1071, I can also install another package called car data, like that. And you don't even need to use the C function. You just list your packages. And the ARA will go and look for the data. I think this one is not okay. Let me check something else. Actually, ARA will go and look for that package. I think something is wrong here. How about ggplot2? Oh, sorry. For installation, it's just one package at a time. When it is activation, there is when you can put more than one. For installation, it is one package at a time. So like that, instead of using install.packages, you can just use p-install and the installing package. Installing package. But the good thing among all is this function here. I think this one I have to edit. Supposed to be for this one, pload. Pload is for activating package. Pload. I think I should say here, alternative for install.packages. Alternative to install.packages. This one is alternative to library and require. To library and require. So you can activate packages. You can activate packages by using pload, but pload does more than that. Like here, I can deactivate a package when I say something like skewness. This is the function. This is the function from E1071. Because the package is not yet active, it says not found. But if I say pload, so pload E1071. If I say pload E1071, now when I say skewness, you see the package now is active. So instead of library or require, it does what? You can use the payload. The good thing about the payload, let me do this first. Remove dot packages. Remove dot packages E1071. E1071. Let me remove it completely. Now, after removing this, if I come here and say library E1071, check if the package is removed. E1071 supposed to be from there. Use another function p delete E1071. Foreign package not found. Okay, good. So if I tell you library, it's supposed to give error because the package is no longer there. I say skewness. Why it is still there? It's supposed to be. Okay, there is a delay of removing it from CRAN. Okay, what I wanted to explain, E1070 payload, unlike a library, for library, if the package is not there, actually it is gone and throw error. It will throw error that the package is so and so not found. But for payload, if the package is not there, it will install that package, and after that, it will activate. So payload, it does both activation and installation. Activate packages and installations. So we prefer this much because payload will do the job of installed packages. It will also do the job of library altogether. So even if the package is completely new, if I say p load, maybe say write Excel. This one will, if the package is not there, will be installed first. Once it is installed, then it will be activated. That is what a payload will do. And you can do that for more than one packages. Just separate them with a comma. Unlike install, this one you have to remove them. Payload is the one which can take more than one package at a time, not pre-install. But another thing which is not there in base, we have p temporary. You can temporarily install a package here. Like if I run p temporary a prof, ARA, Pacman will install this package. But the moment you close your ARA software, the package will also vanish. Next time will not be there in your local disk. So you cannot have this. If there is a package which you want to temporarily use, you can use p temporary function. But also there is other function which is called p is installed and the p is loaded. This one I will explain them very shortly. For the time being, I will skip this because the idea of installation, it is now clearly understood. We have another thing which I'm yet to accomplish this handout. If you want to install a package specific from previous version, like if I say here package version, if I say here, for example, package version dplyr, it is 1.2.1. But maybe in your study, it is recommended to install the previous version like 1.1.0 because it is already archived. You'll go back to use the remote, the same remote which you are using to install GitHub version. Now you will use it to install the previous version. Let me try if this will work. Install specific package version. Install specific package version. You will again use the remote to do that. So this one, to go to Chrome, try to open that one and download the other version. You see it says so and so and so. Yeah, say none. Which one would you like to update? None of them. Number 3. When you have this message, something like this, it says this package have recent version available, and these are dependencies. I don't want to update any because it will take my time. So I'll pick 3 because it is none. Then it will install that dplayer from previous version. Like that. Okay. Now it is compiling. It's compiling. Wait it to finish. Done. So if I rerun this package version now, you see it is 1.1.0. So you can install a specific version. Sometimes there is this demand. You are doing a specific analysis and they say you must use a package version so and so, but it's the previous one. You can always do that by using remotes with packages. Now, package version functions. Package version functions. We have used the one here from base. Package version dplayer. This one. But there is a counterpart from Pacman. If you say P version, the difference between Pacman and this one, for this one, you have choice. You can either enclose it with double quotes or you can ignore. Like here, you can just write dplayer. And it will give me answer 1.1.0. If I remove quotes from here, we'll see what happens. You see error. So for basic functions, always must be enclosed with double quotes. But for Pacman function, you have choices. You can either enclose them with the function, with the quotes, or you can ignore them. Like here, if I just say dplayer, if it is highlighted like this, if I press enter, it will automatically press quote for me. So for Pacman functions, you have choices like that. So you can either use the package version or P version from Pacman. But Pacman now provides something which is more detailed. And what is that? There is another function which is called the P version cron. P version cron. What we have here is the installed version. Now I want to check what version is currently available from cron. P version cron. And in my notes, you always see these alias. This is the package name, this is the short form. So you can use either of the two. Even this one, package version, but you can use the P-ver. So sometimes you find a short form of a name, we can make use of it with no problem. So dplayer. Like in this case, what version do we have now in CRAN? It is 1.2.1. This is the current version we have. Current version in CRAN. So this will give you a clue if you need the update of the package or not. Current version in CRAN. And another function which is important, it is this one, package version difference. This one compares what you have installed and what is available in CRAN. Like here. Locally, we have installed 1.1.0, but in CRAN, there is 1.2.1. So it says what? Local display is behind the CRAN. That is the message. It means you need to update. Compare CRAN and local. Let me check another. Let me do it for another package, which is most recent. How about ggplot4? It says local 4.0.2, CRAN 4.0.2. So what is the message? The local ggplot2 is equal to CRAN. So I have the most recent package. This is the message which you can get by using this. So you don't have this in base. In base, you can only have version, but the advantage of checking which version is currently available in CRAN, you can get them from external function. So sometimes someone may ask, why do we need the external function? First of all, is the simplicity. You may do the same thing, but in a simple way. But the other stuff, some other functions are completely new. They are not there in base function. Like what you have seen here for P version CRAN and P version difference. What else is update? Sometimes you need to update both packages. I've seen back then that we have about 345 packages which require updates. So this function p update also can shorten up as p up. Is a wrap of updates packages. It will update all packages which need updates. I will not run this because it will take a lot of time. So when you want to do this, just leave your computer by the time you're going for sleeping so that you do the job of the entire night. But currently not. But maybe you are interested to know the packages which are out of date. So you can use the function, but make sure you put the argument false within that. If you put that, it will give you the message, how many packages and all the list of packages which require updates. So this is the list of packages which require updates. So when you press update.package without false, it will update all those packages for you. You don't need to do it one by one. Unlike this update.packages, which you are required to specifically tell which package needs some updates. Another stuff is deactivation. You can deactivate the package from working. Like saying p unload package name. Here. Pload is for activation. Pload is activation. Deactivate package. Deactivate. Here I have activated the package. And there is another function called is loaded. So you ask, is the player loaded? It says, sorry, valid atomic vectors is loaded. Check. Is this required? Okay, E1071 is missing or broken. We need to reinstate it. It is a dependence. I think so. So I'll say this, reload first. So pload. Something's wrong. I think there is an update here. Maybe I don't get it. E1071. I'll check the function. It was supposed to return either true or false. It was supposed to return either true or false. Now it did something back then, which now keep throwing error about E1071. Pload. E1071. Is it loaded? Not yet. I'll just give the explanation until when I fix this. So wherever you load the package, it will say it is loaded or not. And along that, you can also have another function called p install is installed E1071. Is it installed? Yes, it is installed. So the challenge is loaded. So as installed, you're asking either the package was installed, is loaded, you are asking either the package was activated. Was the package installed? Is the package installed? Like this one, the package activated. So that is what it does. And you can also remove the package completely from the environment, like remove.package. Here we can use p-delete. So this I will just explain. You can try on your own. So you can use p-delete. I'm not sure if we can delete more than one at a time. Let me check. Sometimes I was just editing name without checking this. Yeah, still to throw this error. I think it is still it is until when I restarted the session. Let me check if I can restart the session here so that I can avoid that. The code says the same. So sometimes instead of closing and reopening R, you can just restart session like this. Just restart session. After restarting a session, it means you need to activate each package. It's like starting afresh. So here, if now I say this, first of all, it will say the function could not be found because I need to go back and say library pacman. I have restarted the session. So first of all, you have to say library pacman. After that, you can proceed. Let's start with this. Is loaded. Now we are okay. Yes. Is loaded false? Is not loaded. But if I say load, and then I say is loaded, it says, just wait. Since it was false, now it is installing, and now it is true. It's loaded like that. P-delete, remove the function. It is accepted. So these one are totally deleted from remove package from environment. Delete package from R. So if I come here and say library ggplot2, says what? There is no package because it is already deleted. But now see the power of pload. If I put a pload, p underscore load, instead of saying ggplot2 not found, I will also put the player altogether. It will look for the package. If it is not there, it will install it. And after done with installation, it will activate it. That's why it is so powerful, more than even library. So that is how it is. So if the package is available, it will just activate it. But if the package is not available, it will look for it, download it from CRAN or any other repository, and then activate it. It is very powerful to use pload. So you may find some people keep using it a lot. Instead of using install.packages, then library, pload is enough. And just list your packages, even if they are 10, no worry. That is pdelete. How about the package information? I have already said about this. Our session information. Our session information. P underscore loaded. Now here, list of activated packages, not installed, only packages which are active. Like in this case, you have only 4 packages. Remember, I have restarted the session. You need all packages which are installed. We'll learn about that. But currently is this one. Don't get confused. We have P loaded. We have P load. And you have P is loaded. These are 3 different functions. This one for activation and installation, for install and activation. While this one, check if package is active. So here you must pass an argument. You must pass an argument like any other package, like matlib E1071. They are not part of this, but since the name are closely related, I have decided to put them there. So for your reference, what you wanted here is just P loaded. But if I say P loaded, then all true. P loaded, then all true. Here it will include the base package. Include the base packages. The first one just give us external packages, but this time around, not only these external. From here, starts, graphics up to base, these are basic packages. When you say all true, it will also include the basic packages. You don't have something like this from base function. What else is loaded so and so is there? Exists. There is a function called exist. This will go to the repository and will look for you. So it requires internet connection. It will go to repository and it will ask, is this package there? P exists. Package existence in CRAN or locally. Package existence in CRAN or locally. So if you say P exists, let me check this, the player. It will go to CRAN or local and ask if the package is there. It says it is there. Now you can install. But what if I say P exists HR? It says false because this package is not in a CRAN. It is in bioconductor. So before you do installs the packages, you can always start with the P exist to check if the package is there. In base, this we got it from here, install packages. When you say install, if I type here dplayer, when the package is there, it will be available here. But when it is not there, like this one, HR, it is not to be found. So in command, you can achieve that by using P existing. Ask if the package is available in CRAN. Local true. What is that? As you can remember, in my computer, I have installed this HR. I have installed this. But when I run P exist, it says false because currently it goes to CRAN and check. It is not going to check in local. So if you even want local to be true, I will come here, check existence in local. Check existence. Local drive. So here, existence. I'll say here local true. It is still false. I think I have installed it. I haven't installed it. So it is not there even installation. So I have yet to install it. I have uninstalled it. So you can confirm like that. It is local or not. Another important part. It is about package dependencies. What is package dependencies? Each time you build a package, even today, if I want to start building a package, I may borrow other functions to use from other packages. So it means I depend on those packages because internally I use their functionality. So like in this case, I want to check which package depends on. If I say here P depends E1071. I can call it parent packages. So it listed here, imports and suggest. I will explain the issue of imports and suggest. They are here, and most of them are base. Not all, but most of them are base. These are packages which E1071 depends on. And there is another package which is called P depends, sorry, function, P depends reverse. What is that? These are packages which are depending on this now. So children, packages. Packages which they borrow function from here. What you get from here are packages which E1071 obtained their functions. But this one now is the list of packages which relies on. So all these more than 103 packages requires function from E1071. So this one is parent for parent packages. This one for children packages. Which package you make use of this? They are very important because sometimes we may decide to uninstall packages. So if you uninstall packages, like if you decide to uninstall E1071, all these packages may not work well because they borrow function from E1071. All these packages. It's not necessarily uninstalled, just to know that how many packages are depending on that. Think about this. P depends is about packages ancestor or parents, while P depends reverse is about packages descendants or children. Packages which rely on P depends reverse, and packages which relies on P depends. Another thing is package information. We have seen this. Package information. We have seen this from base package description. Package description. Is it package description? Yes. Package description is 1071. It's base package, so I have to enclose with it. So what is the alternative here? Is package information. So it will give almost similar information. So the same stuff. So you can use it from base, or you can use it from external. There is one line, I think I have to recall it today, which we have learned it in day 1. Very important line. Let me check. It is here. There are multiple ways of doing the same thing in R. Like here, we achieve the same stuff by using different functions. And at the same time, we may have 3 or even 4. So I'll not talk about that. I won't spend much time here. You can even shorten them by writing pin info. I'll skip the rest. How about extraction? Here, the issue of dependencies also, but I will just define depends. What is the meaning of depends? What is the meaning of imports? What is the meaning of suggest? When I executed this function, you see some stuff here from information. You see imports, you see suggest, and if there is a dependence, you also see them. Imports, suggest. Check. Like here, we have suggest, we have depends, we have depends, we have imports, and we have suggests. Maybe they're there. Suggest, and you have suggest. What is the meaning of this? So here I'll just give the definition. When you see depends is for packages. When you activate that package, it will also install and load those packages because they must use their functionality. When you install, it will also install those packages you are dependent on. Like in this case, where is here? Like in this case, reverse. When you install buyer's LCA, by default, it will also install E1071 and it will also activate it because it is used directly. Wherever the package from here, even if it is MTPS, it will also install E1071 and load it. That is the meaning of depends. So these are the packages which depend on E1071. Here is for packages which are automatically installed and loaded. What about imports? The package which are automatically installed but not loaded. Like here, this one. When you install IS, for example, it will also install E1071, but it will not load it. It will just use it behind the scene, unlike it depends. Depends, it will be installed and activated, but this one will just be installed, but not activated. And what about suggest? Suggest for packages which are not automatically installed and loaded, like in this case. like in this case, suggest if you install this package mpir, it will suggest that you also install E1071 and even load it. But even if it is not there, the package will still work. So that is the discrepancy between depends, import, and suggest, wherever you see them. So like in this case, for dplayer, display dependent packages. You use extract as long as well as the information altogether. How many packages dplayer depends on? It says only R version 4.1. No single packages which it relies on. How about this? How many imports which can be loaded but not activated? Let us see. It says all these suggest the player will load them, will install them, but will not load them. How about suggestion? How many packages the player recommend them to be there, but even if they are not there, it will still work. It is important. It is very well. It is recommended to have them, like this broom or ggplot2. It is not like if they are not there, the player will not function. It will function, but it will be good if they are also there. So these are the suggested packages. So that is the another part. There. The other part is about the author of the package. Author of the package. This want to know the package author so that you can contact, like this one, it is Hadley Wickham. Author, it is closely related to maintainer. Another thing is if you want to cite a package citation, you have used it in your research and you want to cite. So we'll say here p cite a player. It will give you the citation. So you copy this and put them in your reference list. If you are using LaTeX, LaTeX, for you will copy this. For LaTeX user, this is the suggestion. Even the base function has got this citation of the package from base. So it is not like it is from that only. Even base function will give you similar stuff. So this one is from base, while this is from partner. Another stuff is list of packages available to user, packages you installed. So if you say p library, list of packages available in local disk, list of packages available in your local disk. List of them, it is p library. So it will give you a list of installed packages. You remember there were 655 or something like that. So this is the list of all packages which I have already installed. You'll get the same stuff by using installed.packages. What you get from there. Sorry. For this one, you have to put names. Names. Now, so it is call names. Call names. Call names. Installed.packages. Installed. What is happening? Sorry, it is the raw names. Yes, here. Something similar to this. That one ended with 65. Here you have even more. There's a minor difference. But what do you see? The function from base, it is somewhat complex because you have to make use of several functions to achieve similar results. But from deep layer, so from Pacman, simply need to put a single function and it will take care of the rest. But there is this function here, p base, p underscore base, lists of base function, base packages, list of base packages. You see there are 7 data sets, utils, GR device, graphics, stats, method, and base. So you also get the privilege of seeing the base function by using pbase. And now the real thing, access list of package functions. Access list of package functions. List of package functions. This is very, very important. List of package functions. If I want to see the functions from deep layer and I use base function, I have to write ls, then a package, then package name, deep layer. But you see there? So these are the functions from deep layer. So from deep layer, we will make use of all these functions later on when we go to use this. Very important. But Pacman has a simple function for that. You just say p function deep layer. This is from base, while this one from deep layer. It will do the same stuff with ease. So always external function provide the simple alternative functionalities, which is very difficult when you have base function. Another thing is access to list of toy data. Access to list of toy data. How do we access the list of toy data? As usual, also put a base function. Base function is called, like here, the function is called data, and then package data package equals to deep layer, like this. So it will open a text file, separate text file, and tells you this deep layer has a toy data called the band instrument 2, band members, Star Wars, Storm. But Pacman, this is from base. Pacman provide simple alternative by saying data, simply say deep layer. This will print data in console. So this is the difference. The Pacman will give you output in console, while the previous one opened a separate session, text file session. I always prefer the Pacman version. That is my case. Another thing is package documentation. For package documentation, there is what we call the VGNet. In our ecosystem, VGNet is a long-form guide that explains how to use a package. The VGNet shows how to combine multiple functions to solve real-world problems. Simply, you need to write p VGNet and then a package name. You can have one or more than one. Like here, I will say p VGNet white deep layer, and even gg plot2. Here it will go to my browser and open HTML files. Now these are the guides. Like if I want deep layer and base comparison, if I click this, it will show me those comparisons. Like a range function in deep layer, how do we obtain it in base? Like this. Mutate function, how do you obtain it in base like this? All those will see them when we reach to the particular package because it is coming. The lesson is coming about dplayer. Here, I just wanted you to see how you can access those functions. So I can go back and say using dplayer in packages. Which functions can I use? Like here, closest, between, within, overlaps. What is the use of this? So the moment you understand how to use the packages, you can come in and learn the coding style on your own. Or introduction to dplayer. What is the introduction to dplayer? When you're working with this, figure out what you want to describe with those, so and so. There are several stuffs here you can play with. Like dplayer operate on rows, columns, and group. When we reach to the dplayer, we'll learn about that. It tends to explain each function in detail. So, or not. How about ggplot introduction? Here they are arranged by using alphabetical order. So for you, you must make sure you start with the simplest case. Like in this case, introduction to ggplot. Here it gives you a little bit about introduction and even the book, which you can get more details. The hyperlink of the book, like that. So always prefer to visit VigiNet. It will help you a lot to go deeper about a certain package. That is number one. I think also Base also has got VigiNet from Utils. dplayer VigiNet. Yes, Base also have it, but they will be thrown directly from your help and not from browser. This is the difference. The one from Pacman gives you in your browser, while the one from Base will display those stuff from help. So that marks the difference. But all of them provide similar stuffs. I prefer the one from Pacman because it is easier to follow along from browser compared to the one from Base. Lastly, I'm almost there. There is this function called p-interactive. P-interactive, I'll just show you a little bit. Why interactive? It is a meta function which stops on the ASCII for your permission. That's what is called interactive mode for each step. So sometimes we may seek help, but what it does, p-interactive. If I put it here, when I say p-interactive, it will go to all installed packages. It will even assign numbers as you see them there. Like in my case, let me check for dplayer. Dplayer is assigned which number? D. Dplayer. It is here. Number, this is DB player. Let me check this for dplayer. DBI, DB player, dplayer. DP here, 106. So once you know the number 106, you answer it here. This is what you call stops and ask. So I say 106. It means now I'm focusing on dplayer. Do you want to detach dplayer on exit? You say yes, number one. So it throws all function of dplayer from there, all functions. And now you look, are you interested with which function? Maybe I say mutate function, 153. 153. You press there. Do you want to see help from page of mutate? Maybe you say yes. Now it gives you the help. So instead of doing it manually, you can do it by using interactive mode. Each time you take a step, and now you read your help from there. But other than that, instead of doing that, I will come here and say P function of what? Of deep layer. After P function of deep layer, I will go and seek mutate. Where's mutate? M, mutate. This one. Then I'll come here and say help mutate. So you're doing it manually. So you can decide, use interactive mode or to go to P functions, then use help. Lastly is to search packages. For packages which are already installed, you can use P search library. P search library, like you can come here, search package, search package, P underscore search, not N, search packages, search library. And the arguments, if I press tab, it will give me the argument, it begins with, and I say I need the package which begin with MA. If I do this, what it will do? It will list all packages which start with MA, installed packages. And maybe you're interested with this one. Now you say, oh, I want to focus on that one. Matrix calculate is loaded. Now I can use it. But another style of using this is P search library. Instead of begin, I will say contains. Because begin restrict the content to be at the beginning. But if you say contain MA, wherever MA is there, that package will be loaded. Like this US map, it is loaded because of this. Matrix is loaded because of this. Rematch is loaded because of this. So you can check, you can use that one. Contains. Or you can decide to use both. You can decide to use both. Contain MY, sorry, start with MY, and maybe contain, you can put another letter, maybe B. Is there a package which qualifies that? You don't have it. How about C? Have it. How about start with A, but contain X? No. So sometimes the combination may be difficult. It is recommended to use one of the two. If you combine them, it is so strict. And when do we use this? Sometimes you remember partial letters of the package, but not a complete name of the package. So when you remember just some of the content, partial matching, you can always look for a package by using P search library. These are libraries which are already there, already installed. But you can also look for a package from Package Finder. This one will go to the internet for you. Package Finder, first of all, you install this. Now we are Package Finder. Me or just library it. Package Finder, as the name suggests. The function also is the package Finder. Find the package here. Find the package. How do I use this? You can first ask for help. Help. Libraries. Help. So here, Package Finder or searching CRAN. The first one is to put a keyword. Like, I need the function for linear regression or logistic regression, for example. Which package can do that? It will go and look for that package for you. So you just ask anything. Please wait while index is being searched. So it returns 202 out of that. And it gives you the long list of those. So you pick either of these. Here it goes to the CRAN and they look for the packages for you. So it gives the score, like this one, log reg equivalent. It is more recommended. The score is 100. Logistic regression. So after this, what do you do? Once you have found the promising package, you can make use of the go function. Simple function go will help you to go to the package CRAN and the web page, or will help you view the PDF. So I can come here and say go. Which package? Check like this one. Log equivalent. Go. Is looking for that. Not found. I think it requires double quotes. So like that, keeps use go 110.50, then manual to view the manual package. So I can take this. And then it will bring a manual for us. So you see, it even brought the manual. So you can read the package manual here and understand all those stuffs. So this is how you can search external packages from here. So you can use the package finder and go. And that marks the end of today's session, unless there is a question. But this is all stuff we can say about the package management. After this, we are done. Jamani, kama kuna swali. Leo nimetumia masaa zaidi sababu nitaka karibu.
Nani? Oh, sorry. Reguma.
Karibu.
Halo. Yeah, kwa hiyo kama nikitaka kufind package, lazima kwanza ni library, lazima kwanza ni library package finder.
Yes.
Alafu ndo niende kwenye help.
Yes, unatoka kwa library package finder, then utumie hii function find package. Hapa sasa unaandika content yako. Package hiyo inafanya nini? Yaani inawezekana hujui jina, maana ndio kwanza unaitafuta.
Exactly.
Yes. So andika content.
Kwa lazima ni yani ku library lazima.
Alafu unaenda library kwanza.
Una library alafu unaenda help.
Yeah. Hii help ni kwa kujifunza tu. Lakini ukishazoea you can even ignore this part. After library just go direct to package finder.
Package finder.
Yes, alafu ukishaandika hapo go package name. Ukishaandika go package name itakupa hii suggestion. Lakini kabla ya hii suggestion kuna kitu kilikuwa pale, ngoja niwaonyeshe. Ukishazoea you don't need that. Check zoom this. Yeah. Check this. You see this go. E number. This is the number associated with this package. So always you want to check the manual, utakuja hapa kwenye number reference, utaichukua utaenda kwenye manual. Kwa mfano, kama ningekuwa nataka manual ya huyu BC Logit. What should I do? For BC Logit. BC logit. If I need that manual, I'll just say go, and then I pick this number here, 1359. 1359. Then it will fetch manual for me. Here. Is here. So just know how to make use of that. Nitaidokumenti vizuri ili waongoze step by step. But this is how you do it. So this is the meaning of go. So for any other package, it is also possible. Unless kama kuna swali jingine pia. Abdalla.
Amtakanigumu.
Wewe mimi ndio umezoea una orodha ya maswali, sasa leo unanikaushia.
Naam?
Umezoea maswali ndio yanatokaga huku.
Tuko vizuri mwalimu.
Aise, basi kama hakuna maswali ya ziada,
kuna mdogo wako hapa na swali.
Ehe.
Karibu. Mwalimu.
Ndio.
Mwalimu, mimi sijaelewa, umetokeza kwa Kiingereza afu maswali kwa Kiswahili, hapo ndo sielewi.
Wewe toka.
Hayo masiara hayo.
Alfreda.
Najuta kumpa.
Mimi nijua Zahoro, kama ni huyo ni mchomaji.
Kumbe hii shule ina watu wengi.
Kaka.
Ehe, Zahoro.
Ilikuwa nataka niulize ila lakini jamaa Magoti hapa kashalipeperusha swali langu basi tu.
Chenga hiyo.
Chenga kabisa. Asante.
Alfreda.
Okay. Good evening, sir.
Good evening, how are you?
Sasa ilikuwa nauliza kwenye ile function ya P depends,
yes,
ambayo inakupa the parent package.
Yes.
Alafu kuna ile P depends diverse.
Depends reverse.
Reverse, yes, inakupa the children
packages, yes.
So it means kwamba je, niki-install the parent package nitakuwa naweza ku-access the children package, au natakiwa ni install the parent package then ni install tena na the children package?
Don't worry, hapa about depends the reverse is about knowledge only. Lakini kila package utakayo install ita-install dependency wake yenyewe. Yaani sio kwamba unatakiwa ukatafuta manual, yenyewe ita-install. Ila sasa itategemea na level. Je, ni depends au ni imports au ni suggests? Sawa?
Okay.
Yeah. Lakini kila package, yani hakuna kitu utaenda kufanya manual. Kila package inajua where to pick their dependents and their ancestors. Kwa hapa unachokifanya ni knowledge tu. Ujua ipi na depende kwa nani.
Okay, thank you.
Karibu. Yeah. Yatakuwa yameisha. Mdau Saga?
Hapana, sina swali lolote.
Sawa, nadhani wiki hii exercise itamwagika. Ubizo umeisha. Basi Mungu